They want to know if the following functions are inverses of each other. So in part I, the first one, we've got a line and another line. Are they inverses of each other? Well, we can check that to find the inverse of y equals 3x minus 6. What are your steps? First step, you switch x and y. So then I would get x equals 3y minus 6. And then we solve for y. So I'll add 6 to both sides, divide both sides by 3, and the equation of the inverse would be x plus 6 divided by 3. Does that match with what they wanted? No. So in the first ones, they are not inverses of each other. The second one has a restricted domain. So just a note up here, I'm going to label that. We're looking at negative x squared plus 3, but only for x bigger than or equal to 0. In other words, we're only looking at half of the parabola. So if I wanted to find the inverse of y equals negative x squared plus 3 with the restricted domain of x being greater than or equal to 0, well, how do I find an inverse? We start off by switching x and y, just like everywhere else. So I get x equals negative y squared plus 3. Subtract 3 on both sides. Multiply both sides by a negative to get the item that's squared all by itself. Now we can square root the question is, though, there was a restricted domain, so we need to figure out, do we take the positive one or the negative one? Okay, so a little note off to the side. Since x is greater than or equal to 0 on the original function, y will have to be greater than or equal to 0 on the inverse. And if y is greater than or equal to 0 on the inverse, well, then our equation has to be the positive one. Right, oops, go. That should just be y, right, because I square rooted both sides. Does that match up with what they have? They have 3 minus x. We have minus x plus 3. Are they the same? Yes. Right? This is equal to so if you want to find out if two things are inverses of each other, you take one of the equations, find its actual inverse doing the process of switching x and y and solving for y, and if the equations match up, then you'll know that they are inverses. In part B, it says verify both of these graphically. So what I'm going to do is I am going to, for part I, graph both equations. So we had 3x minus 6. So to check out the first ones, the first two equations were y equals 3x minus 6, which I'm going to graph in green, and y equals x minus 6 divided by 3, which is the same as 1/3 x minus 2. So some algebra skills that you'll need is, can you change something like x minus 6 over 3 to be 1/3 x minus 2? Because if you can, it makes graphing a lot easier. What is 3x minus 6 looks like? Well, it's going to have a y-intercept at -6 and a slope of 3, up 3 over 1, up 3 over 1. There's the equation of our green graph. And our black graph has a y-intercept of -2 and a slope of 1/3, up 1 over 3, up 1 over 3, which looks like this. The question is, graphically, have they been reflected over that line? If you take the green graph and flip it over the purple line, does it match up with the black graph? No. So we can see graphically what we figured out algebraically, that these are not inverses of each other. For the second one, we had negative x squared. I'll do negative x squared plus 3, where x was bigger than or equal to 0. I'll do in green. And the inverse was the square root of 3 minus x, which I'll do in black. The black one, though, isn't in a form that we normally graph. Normally, in our square root equation, we would have the negative x first and then the plus 3. And since this has a horizontal reflection and a horizontal translation, we would write it in factored form. So the green one first. It's a parabola, been flipped down, moved up 3 units. 1, 2, 3, over 1, down 1, over 1, down 3. Oh, wait for it. And we only draw the part where x is bigger than or equal to 0. So I only draw that part of the parabola. What does the graph of negative, the square root of negative, and then x minus 3? The negative would take your square root graph and flip it over the x-axis. No, it's inside. It would flip it over the y-axis. And then you would move 3 to the right. So it's been flipped over this way, moved 3 to the right. Does this one look like it's been reflected over the line y equals x? Yes. If you look at specific points, we have 0, 3 on the green one. We have 3, 0 on the black one. Our x and y values have been switched. So we can see graphically that these ones were inverses of each other. I would have lost a half a mark on my first graph. Does anyone know why? purple dotted line having arrows is actually okay because it is a dotted line that continues forever. I didn't label any kind of scale. So how do we know that these go by ones and not by thousands? Because that makes common sense. I agree, but the exam marking people don't. They would say that you haven't labeled anywhere what your scale is. So if I label this point as 0, -6, and this point as 0, -2, I've labeled some points, but I would still lose a half a mark. By labeling those points, I make sure that everybody knows on my y-axis that I'm going by ones. But do I have any information anywhere that my x-axis is going by ones? No. So I could label another point, or it is as simple, if I put a little 1, a -1, and -2 under there, then it becomes obvious, and then the rest would be fine. But we need to label our scales somewhere on our graph. On the second one, I labeled something on my x, something on the y. It becomes clear what both my scales on my x and my y are. Okay, questions for practice on this one are 7, 8, 11, and 13. And 11 and 13 are a little bit different. They'll make you think.